Assalamualaikum and salam sejahtera. Before we start, let's recite doa first. So today we are going to learn on how to solve the non-homogeneous wave equation. By the end of this class, you will be able to solve non-homogeneous wave equation by eigenfunction expansion method. Now let's proceed on the introduction of non-homogeneous wave BVP. So here is the non-homogeneous wave equation where we have the non-homogeneous term which is F as t. So this F as t is known as an external driving or damping force acting on the string. Same as heat equation, a BVP is called non-homogeneous if PDE, boundary conditions, or either one is non-homogeneous. So we have two methods to solve the non-homogeneous BVP. The first one is decomposition method. The second one is eigenfunction expansion method. We use decomposition when the damping force or external force only depends on X or used for non-homogeneous boundary condition. Eigenfunction expansion is used when the damping force or external force depends on T or on X or on X and T with homogeneous boundary condition. Now let's try to solve this non-homogeneous wave boundary value problem. So this one is our PD equation. We have UTT is equal to UXX plus 4T sin x plus 2 sin 2x. Our x is in between 0 to pi. And this one is our boundary condition. This one is initial displacement and the last one is initial velocity. Find UXT using eigenfunction expansion method. So for the first step, write down the eigenfunction based on the boundary condition. So this one we have sine and pi x over L. So we just substitute our value of L, which is pi, and then we get sine and x. Now let's take a look on the PD equation. So this one will be solved by U as t, and this non-homogeneous term we will solve by F as t. Now let's do for U as t first. So we have the summation of U and t times with the eigenfunction. So this one is our U and t. Our eigenfunction is sine and x. So this one is our F as t, where we have the summation of f and t times the eigenfunction. So f and t times eigenfunction is equal to F as t. So our F as t is in the PD equation, which is 4t sin x plus 2 sin 2x. Next, let's substitute the value of n here. Let's say we do for n is equal to 1. So we will get f1 t sin x, and then we do for n is equal to 2. We just substitute 2 here. So we get f2t sin 2x. Okay, we do till 2 only because we want to compare with the right side. So by comparison, we have sin x on the left side and also on the right side. So our f1t is equal to 4t. And then for sin 2x, we have f2t is equal to 2. For n greater than 2, f and t will be equal to 0 since we cannot compare to the right side. Now we are going to differentiate this equation with respect to t and also with respect to x based on the PD equation. For wave, we have UTT is equal to UXX. when we differentiate this with respect to double s, we will get this one. And when we differentiate this with respect to double t, we will get this one. And now we are going to substitute into the PDE that we have. So we just write it back. We will have UTT equal to USS plus FST. So our FST will be this one, FNT eigenfunction. And then we just equate the coefficient of sine and s. Then we will left with un double prime t plus n square un t is equal to f and t. After we equate the coefficient, we need to substitute the value of n that we get before. So we just do for n is equal to 1 and also n is equal to 2. Okay, now let's do for n is equal to 1. We will get u1 double prime t plus 1 square u1 t is equal to f1 t. And then for n is equal to 2, we will get u2 double prime t plus 2 square u2 t is equal to f2t. Then we can use the value of f1t and f2t that we obtained from step 1. So f1t will be equal to 4t and f2t will be equal to 2. Just write it back for n is equal to 1. So we have u1 double prime t plus u1 t is equal to 4t. So this is called as second order ODE. This method can be solved by using the undetermined coefficient method. Where we have u1t is equal to u1c plus u1p. So u1c is the complementary method and u1p is the particular method. In order to solve u1c and u1p, so we are going to split this equation. So we will have u1 double prime t plus u1t is equal to 0. And then by using the auxiliary equation, we will get m squared plus 1 is equal to 0. So our m will be plus minus I. Then our complementary equation is a cos t plus b sin t. In order to find the u1p, which is the particular method, we need to let u1p is equal to ct plus d. Now we are going to differentiate with respect to t. So we will have u1p is equal to ct plus d. And then u1p prime will be equal to c. And then u1p double prime will be equal to 0. Now we are going to substitute into this equation. So our u1 double prime t is equal to 0. So we have 0 here. And then u1t, we have ct plus d. So just write down ct plus d equal to 4t. Okay, and then we compare the left side and the right side. So the right side we have only 4t. So the left side is ct, means that c is equal to 4. and D will be equal to 0 because we cannot compare with anything from the right side. And then we substitute into this equation again to get the particular value, which is U1P equal to CT plus T. Means that we have C is equal to 4 and D is equal to 0. So we just write it back. We will have U1P is equal to 4T plus 0. So the final will be U1P is equal to 4T. Now let's write the general solution. So here is our general solution. U1T is equal to U1C plus U1P. So our U1C is equal to A cos T plus B sin T. And then our U1P is equal to 4T. Just write it back. We have U1T is equal to A cos T plus B sin T plus 4T. Now we are going to solve for n is equal to 2, where we have U2 double prime T plus 4U2T is equal to 2. And this one is our general formula. So in order to find U2C, we are going to make this equal to 0. So by using the auxiliary equation, we will get m squared plus 4 is equal to 0. Then m is equal to plus minus 2i. And U2C will be equal to E cos 2t plus F sin 2t. In order to find the U2P, we must let this one is equal to G. We need to do the same thing as before. We need to differentiate with respect to T. So when we differentiate with respect to T, we will get U2P double prime equal to 0. Then we just substitute into this equation again. So our U2 double prime T is equal to 0 plus 4 U2T is equal to G is equal to 2. Then G will be equal to 1 over 2. Now let's just write the general solution where we have U2T equal to U2C plus U2P. And we will have E cos 2 theta plus F sin 2 theta plus 1 over 2. Now we are going to find the value of A, B, E, and F in the general solution. So from 1, we have U at T is equal to U1T sin x plus U2T sin 2x. This one is the general solution for U1T. This one is the general solution for U2T. So we just write it back and we will have like this. Now we are going to use the initial condition in the BVP. So we have U at 0 is equal to sin x. So we just substitute T is equal to 0 in the general solution. So cos 0 will be equal to 1. Sin 0 will be equal to 0. 4 times 0 will be equal to 0. Cos 0 will be 1. Sin 0 will be 0. And then we will have A sin x plus E plus 1 over 2 sin 2x equal to sin x. And then by comparison, we have sin x only. So our A will be equal to 1. And then for sin 2x, we cannot compare with the right side. Then it will be E plus 1 over 2 equal to 0. Then our E will be negative 1 over 2. since this is the wave equation, we have another initial condition, which is ut at 0 is equal to 0. But we cannot apply directly into UST because this initial condition is applicable for UT, means that we need to differentiate the general solution UST. So when we differentiate UST with respect to T, we will get this one. After we get the UTST, we can apply this by substituting T is equal to 0 in this equation. So when we substitute, sine 0 will be equal to 0, cos 0 will be 1, sine 0 will be 0, and then cos 0 will be 1. Then just write back, we will left with b plus 4 sine x plus 2f sine 2x equal to 0. And then by comparison, we know that b plus 4 is equal to 0, then we will get b is equal to negative 4. And 2f is equal to 0, then f will be equal to 0. Lastly, we just write back the final solution, which is temperature distribution U at T. That's all. Thank you.